Welcome back to another tutorial video in this calculator series. If you missed the last video, you can go back and get the link for the full playlist in the description down below. Or if you hate building UIs and you just want to jump right into the logic, you can also get the starter code for this video in the description below. So as promised, we're going to jump right into our view model creation in this video. So in your presentation layer, let's make a new Kotlin class or file. And we are just going to call it calculator view model. And so this view model is essentially going to have a reference to the state, and it's going to allow us to track our state whenever any configuration or rotation changes happen on our calculator, or if we whenever we need to update something, because right now you can push all these buttons on the calculator and it does nothing. So we need to track all of that in our state. So the view model is what we're going to be using to update our state in this calculator. So this calculator view model is going to be extending the view model class. And then inside of that, we're going to have a variable called state by mutable state. So this is going to be our reference to our calculator state. By mutable state of calculator state. And then when you add this, actually, I don't know why, this must be a bug in Android Studio. It's not importing everything we need by default. So it imports that mutable state of, but you also need the get value and the set value for that. So there we got that get value, but we also need the set value. So let's see. Yeah, so make sure to import the mutable state of, the get value, and the set value. And then let's jump right into it. So I told you earlier when we were building the sealed classes for our button action and then for our math operations that sealed classes pair very well with when statements. So in here, we're going to have a function. We're going to call it fun on button. And that function is going to take an action of type button action. And what we're going to do inside of there, we're going to put a when statement, and we're going to pass it our button action. And then in here, we need to exhaust all the possibilities of button action. So if you remember in our button action class, we have clear backspace equals, decimal, negation, operation, and then number. Pretty much any possibility for a button that we can press on our keyboard. So we need to, in our when statement, we need each of those possibilities. So is button action dot, copy that because we're going to type that a lot, number, then we need to, we're going to write these functions in a little bit, but I'm going to call it write number, action dot number, lowercase there, action dot number, and then is button action operation, then we're going to write the operator. We're going to pass that action dot operation. Is button action dot equals, then we're going to pass it. We're going to pass our calculate function, which we don't have any of these functions yet. We're going to make all of these in a minute. Is button action decimal, we are going to pass it our add decimal function. Is button action negation, then we're going to pass it our negate function. And then is button action clear, we are going to pass it a function that we're going to call clear screen. And then is button action backspace, we're going to have a function called backspace. So you can see this when statement is really easy to pair up with all of our possibilities, within our sealed button action class. Now that we have our when statement completed, we just need to come in here and implement all of these. If you hover over them and just hit create, it'll go ahead and make all the declarations for these functions for you. Write operation, make sure to import math operation on that one, and then write number. So for this, we're just going to start right from the top and start writing our code for the view model. In the write number function, we're going to need a couple different Boolean variables to determine our logic, what number we need to write. Is this going to be the first number or the second number? So to do that, I'm going to make a val, and we're going to call this one display number. This is going to track our number that we want to be adding to our display. And then we're going to have a Boolean operator here called isFirstNumber. And that's going to be equal to if state.operation equals null. And the reason here, so let me switch calculators and show you on my complete one. So if I have a number that I'm entering here, so in this case 9, if I don't have an operator yet, and I push 9 again, I want to write to that same number. But if I do have an operator here, so minus, now if I push a number, I don't want to write to that same number, I want to write to my second number. So that's what this isFirstNumber here is looking for. And the reason I put it in a variable with a name is when I come back to this code, we're going to have an if statement down here. If isFirstNumber. When I come back to this code, it's going to be much easier to look at this if statement and know exactly what it's doing versus if I had if state.operation equals null in here. That would just be it would take me longer to remember what I was doing here. So I like to have my Boolean logic variables saved in a meaningful name that I can know what it is without having to have a comment there. So down here, we're just going to set our display number equal to state.number 1 plus our new number dot to string. Oh, so new number, I'm going to name this, actually this variable coming in, I'm going to name new number instead of number. So if it's our first number, we're going to set our display number equal to that. And then we're going to do a state equals state.copy. And within there, our display number is going to be equal to our local display number in this function. Our number 1 is also going to be equal to our local display number in this function. And our current equation that we're building is going to be equal to this display number in the function as well. And then if that is the case, we're done and we can return. Else, if we want to write to our second number, so our display number is going to be equal to our state.number2 plus our new number dot to string. So that should look familiar. And then the same thing down here, we're going to have state equals state.copy. And within here, our display number is going to be equal to our local display number that we've created. Our number 2 this time is going to be equal to our local display number that we created. And then our current equation is going to be equal to state dot current equation plus our new number dot to string. So now that we're on our write operator function, before we jump into that, I'm going to add a couple of private functions down here that we'll need. If you look on our calculator, you can see we're displaying our number, whatever number we're currently entering. We're also displaying the equation that we're currently building. So we need a way to create that equation. So I'm going to make 2 functions down here. One for creating a partial equation, and then another for creating a full equation. So first we'll do the full because that one's going to be fairly simple. It's going to be private fun write full equation. And then this is going to take a double, which is going to be the result from any calculation that we do. And the reason we're only taking the result is because we already have a state in that we have a calculator state variable in our view model. So the result of the calculation is going to be the only thing that's not saved in that state. So if we want to write the full equation, let's make a variable down here, val result string equals, and then this is going to be result dot toString. Now we could do that, but that's going to give us a problem. If we do 1 plus 1 should be equal to 2, this is actually going to give us 1 plus 1 equals 2.0. And the reason is because we're doing a toString with a double. Now we could just format that right here, but the problem is we don't want to do that because sometimes we want that decimal. So we need to determine if this is a whole number or not. So before we do that, I'm going to come down here and make another function, private fun is whole number, and this is going to take in a double. And all we're going to do is determine if the double being passed in is in fact a whole number. So if number, and the way that we're going to determine if it's a whole number is modulus division 1. So if number modulus 1 equals 0.0, then that means it's a whole number. So we're going to return true. If it's not, then we're going to return false. Okay, so instead of doing result to string, we need to do, if it's a whole number, we need to do a result to string without the decimal, whereas if it's a integer, or rather a decimal number, we need to do result to string with that decimal number. So I'm going to make another function here, private fun drop zeros after decimal, and that's going to take in a double, and it's going to spit back out a string. And what we're going to do, we return if is a whole number, and then a number. And then in here, we need to return that number, but we need to return it formatted without decimals. So how are we going to do that? Well, first, let's finish this function up here, this if statement. Return number.toString. So if it's not a whole number, we definitely want the decimals. But if it is a full number, well, then we need a way to format this number. So I am going to create a extension function on the double class itself. So private fun double.format, and we're going to pass it in our scale, which is just going to be an integer that determines how many decimal places we want to show. And then inside that, we're going to do quotes % dot, and then our scale variable after that, an f. So that will that's going to essentially take it and display that many decimals. So if I put 0 for my scale, then it's going to display no decimals at all. Whereas if I put 5, it'll display 5. So here we're going to do a dot format on that, and we're going to say this because we want to format this double that we're modifying. So now let me clear out that comment, and what we want to actually do here is if it's a whole number, then we want to format with a scale of 0. So now coming back up to here in our write full equation function, we don't want to do just result to string. What we want to do is drop zeros after decimal result. So that's going to give us, it'll give us the same as result.toString, if there are decimal places, and if there's no decimal, it'll give us the integer number of that instead, which is exactly what we want. So now we're going to do a val equation equals if state dot operation does not equal null. In other words, if there's two numbers, because over here, if our operation is not null, then we have a number 1 and a number 2. Then our state dot number 1 plus quotes, and that's just going to be a space, plus state dot operation dot symbol. And the reason that we have to do a non-null assertion here is just above, we're checking if our state.operation is not equal to null, but now we have to check if that symbol within the operation is not equal to null. Well, we don't have to check. We can just assert that it's not going to be because of the way that we set that up. And then plus state.number 2 plus an equal sign plus result string. And if, let's see, if our state operation does equal null, then our equation is just simply going to be number 1. And then after all of this, we can just return that equation. So that's if we want to write our entire equation, like we have up top over here, where you have 98 divided by 2 equals 49, but we also sometimes need to write a partial equation, particularly when we're building it. So if you have 99 minus 909, like we have here, you see there's no equals and there's no result on the end of that. What did I do wrong here? I need a plus sign there. Okay. So sometimes we need to write a partial equation. So private fun write partial equation. And that is not going to take in a result because if we're writing a partial equation, by definition, there is no result yet. That's going to also turn back a string, and it's going to do the same type of thing here. Val equation equals if state dot operation does not equal null, then we want state dot number 1 plus plus a space there, plus state dot operation non-null dot symbol plus state dot number 2. So now, and then if our state operation is equal to null in this point, in this case, same thing, state dot number 1, and then return that equation. So now we should have all of the functions that we need down here to finish out our when statement up here. So we did the button action number. Now, what about the operation? Let's do that one next. So we're going to go ahead and implement this write operator, function. So in here, there's a couple different times we should be writing an operator. So if I clear this out, if I have 2 and then I hit minus, well, that's the first and most basic case, but let's say I change my mind and instead of minus, I want to write plus. Well, I need a way to overwrite the one that was already there. Or now I have 2 plus 2, so 2 plus 2 is going to be equal to 4, but if I hit plus again, what you could do is just keep building this 2 plus 2 plus 2 and have a long equation, but what I chose to do instead is if I hit another operator at this point, we're going to go ahead and count that as a calculate. So we're going to calculate 2 plus 2, and then we're going to do that next operator with the result of that, which is 4. So if I hit minus now, I'm going to do 4 minus. So we need a way to track these. So first, I can have a value in here, and I can call it is first operator. And I know it's going to be the first operator that the user entered if my state.operation is set equal to null, because that means we don't have an operator yet. And then I can do val should overwrite operator, and that's going to be equal to state.operation. If state.operation is not equal to null, and state.number2 is equal to the empty string. So this would be, like in this case, I have 4 minus. If I want to change that, it'll change to whatever I click. So we need that to track that case. And then we'll do another one. Val should use last result. So if I do 4 minus 2, and I hit equal, well, now I have 2 as my result, and that's what I'm displaying as my display number in my state. But if you look at the equation is blank. So now if I hit minus, I don't want to have 0 minus something. I want to have the result from my last equation minus something. So if I hit minus, that's 2. So I need this variable to track that. Should use last result equals state.number1 equals blank, and state.displayNumber does not equal blank. Oh, up here I need a double equal on that. We're not assigning it to that. Okay, and then one more already has operator need to calculate. And I know these are kind of long names, but I like to name my variables in a way that when I come back to this code later, I'm going to know exactly what this is instead of having to figure out what like state.number equals empty string and state.displayNumber does not equal empty string. Well, that takes some thinking to figure out what exactly I'm trying to get at. So I like to put it in plain words next to that and store it in a variable with a plain word label so that when I read the code later, I can see what's going on. So state.number1 does not equal an empty string, and state.number2 also does not equal an empty string. So if neither of those equal an empty string, that means if I hit something again, if I hit minus now, I need to calculate the result of this, which is going to be -6. And then from that, I need to run that -6. So now that we have all of those, let's go ahead and build out our if statement here. So if should use last result, well, then state is just going to be equal to state.copy. And in here, we need to change our operation equals operation, and then number1 equals state.displayNumber. So next, else if already has operation or operator needs to calculate. So in here, we're going to run our calculate function, which we'll define here in a minute. Then we're going to do state equals state.copy. And within that state.copy, we need to update our operation equals operation. And then our number1 equals state.displayNumber. And then after that, we can do else if is first operator or should overwrite operator, because the result is going to be the same. What we're going to do is we're going to do state equals state.copy, operation equals operation. And then now beneath all of this, so this if statement here, this if else statement is going to set our operator within our state, but now we have to define the function, the formula, the equation that we're displaying on the screen. So one more state copy down here, state equals state.copy. And this time we're just going to update our current equation equals right partial equation. So now that we have that, that should be everything we need within our right operator function. So this top one here should use last result. If I hit -6 minus 6 equals, so now if I hit an operator, that'll use the last result like that. And then the second one already has operator, needs to calculate. So if I have 12 times 1, or -12 times 1, and then I hit minus, it needs to calculate this before it can do the next operation. So that'll do that. And then down here is for if we don't have an operator yet. So I have nothing here. So I hit my multiplication or my minus or my division or my addition. That's what this case is for. And then this is at the end, after that if else statement, is just simply to update the formula that we're displaying or the equation that we're displaying on the screen. So now that we have all of that, let's go ahead and do our calculate function as well so that we can display something on the screen. So in here, we're going to need two numbers that we're doing our math with. I'm going to call them operand 1 and operand 2. And we're going to get those from our number 1 and number 2 from our state. And we're going to do it to double or null. Because if it's empty, it could potentially be null. If it's an empty string, that is. And then operand 2 equals state dot number 2 dot to double or null. And then once we have that, this is just going to be a fairly simple if statement with a when statement inside. So first we need our if statement to verify that our operands are not null. So if operand 1 does not equal null and operand 2 does not equal null, then we need to go ahead and run our calculation. So in here, we'll do a result, which is going to be a type double. And then we'll do an equation, which is going to be of type string. And then after that, all we need is a when statement on our state.operation. So we need to exhaust the possibilities of what this operation could be within here. So we're going to do is math operation dot, and then let me just copy this first a few times and then we'll come back and fill it in. So the first one is going to be dot addition. Next we have dot subtraction. And then we have dot multiplication. And then we have dot division. And then down here, just if it's anything else, we're going to return. Okay, so in here, we're just going to do result equals operand 1 plus operand 2. And then our equation is going to be equal to write full equation with the result. So the string that comes back from our write full equation function that we just defined. So now if I copy this, paste it in each of these, we're going to go ahead and leave it addition there. This one needs to be subtraction. This one needs to be multiplication. This one needs to be division. Okay, and then that is everything we need for the actual calculation. So beneath that, all we need to do is update our state, and our calculator should be good to go. Well, at least for this part of it. State equals state.copy. And then within our state.copy, we are going to need to update quite a few things this time. So our display number is going to be equal to drop zeros after decimal of our result. Because if that's an integer, we don't want any .0 on the end of it because we're coming from a double, and it does that if you're doing a two-string function. And then our current equation, we're going to set equal to blank because we just calculated it, and now there is no current equation. The operation is going to be equal to null. And then number 1 and number 2 are both going to be equal to an empty string. And then finally, our equations is going to be equal to, which this equations is the list of equations that we're storing in our history for the display up top on your screen over here. So equations is going to be equal to state dot equations plus equation. So now we should be good to go. We haven't done our decimal button, our negation button, our clear or all clear button, or our backspace, but we'll go ahead and do those in the next video. If we hop on over to our main activity, we should be able to update this with everything that we need for our, just to test out our calculator and make sure that we did everything right. So hop on over to main activity, and in here, within this calculator theme, we're going to do val view model equals view model, and then this is going to be of type calculator view model. Create. Oh, you know what? Come down into our Gradle module file at the app level. I think we definitely missed something in here. Implementation, Android, this top one here, Android X lifecycle view model compose 2.5.1. We're definitely going to need that to use a view model. So sync that, and then come back into the main activity, and we should be able to import that now. And now, instead of making a new calculator state, our state is going to be equal to our view model dot state. And then this on button press is going to be equal to our view model on button function. Okay, get rid of this unused import statement up top. Now I should be able to run that, and we can see what our calculator actually looks like. So if I have 9 times 6, there we go, 54 minus 5. So you can see this is actually working as we hoped it would. Divided by 4, and it's building our list of equations up here. The only thing that we are not doing yet is our backspace button is not going to work. Hang on. Which calculator app am I in? Yeah, so our backspace button doesn't work yet. In fact, it crashes the app if you click that. So what we're going to need to do is go ahead and define our functions for our backspace, for our all clear, and then for our decimal. And we'll do that in the next video. I'm going to put all of this code down on GitHub, and you can access that link in the description below, and we'll see you in the next video.